Hey guys, Mr. Kyle, Myers Mathematics, and let's just jump right into it. This is multiplying rational expressions. So rational kind of basically just means it's a fraction. Doesn't like have to be, but it's basically a fraction. So that's like the basic definition. A more exact definition would be if you take an integer, so a positive or negative whole number, and divide it by another integer other than 0. So that's like the more technical definition of a rational, but basically it's a fraction, and that's what all of these are. They're all fractions, right? So when we're doing multiplying, but we're dealing with rational expressions, then we're also kind of doing dividing as well. We're doing multiplying and dividing. So when they say multiplying, then they're also talking about dividing, because multiplying is right there. Rational means you are dividing. Rational is division. So we're multiplying and dividing expressions, numbers, letters. So the most basic way to do this would be to multiply across. But if you have to do this without a calculator, that's going to get really rough really fast, because I don't know what 59 times 80 is off the top of my head. I could figure it out off the top of my head if I needed to. But if I don't need to, even better. Now, I actually don't think there are any common factors of any of the numbers on the top with any of the numbers on the bottom. Not that I can see. Which is unfortunate, because it means we do have to multiply across after all. But let's go ahead and do that. But besides the letters. But let's just focus on the numbers for right now. So 59 times 80. And if you are using a calculator, you can maybe like scrub ahead just a little bit, like 10 seconds at a time, or speed it up a little bit. But I'm going to assume that you're not allowed to use a calculator, or that you're just trying to not use a calculator because you feel like it's the right thing to do. So 59 times 80. If you want to do that in your head, here's how. 80 is 8 times 10. When you multiply a number by 10, all you do is you add a 0. So let's put that in our pocket for right now. We're going to save that till the very end. We'll add a 0 to the number at the very end to get our final answer. 8 is 2 times 2 times 2. 2 times 2 times 2. So it's 3 2s. So that means I'm going to double 59 3 times. So assuming you're decent at doubling numbers, that's another thing we could do instead of multiplying by 8. So 59 times 8 would be 59 doubled 3 times. 59 doubled is 118. And double it again, you get 2, 3, 6. And then double it one more time, 4, 7, 2. Whew. 472. So 472 is 59 times 8. 472 is 59 times 8. And then we just add a 0. Whew. Okay, so that is 59 times 80. There's also an in, so we're just going to stick that on the end. All right, on the bottom, 99 times 33. This one's going to be interesting as well. Well, it would be 11 times 11, and then times 27. That would be one way to think about it. But I don't know if there's a good way to do this one in your head. Let me know if you can think of something in your head off the bat or whatever. I don't think I can. Other than maybe to do like a Pascal's triangle, but with 3's maybe. But I don't even know if that would work. 3, 6, 3. Because it's like 33 times 33 be 33 squared. Yeah, let's do it. So I'm gonna use the calculator just to check my math here, but I'm wondering if maybe we could do a Pascal's triangle. Sorry if I'm being a little bit confusing for a second. I'm trying to think of the best way to multiply that number in our head without having to use a calculator. No, Pascal's triangle doesn't work for that. Okay, it's 1089. So what we could do then is, if there isn't a good trick, and I can't really think of one. If you're watching this and you can think of a good trick, let me know. You can either send me an email, because my email is in the description below. That email is in the description below so that you can reach out to me if you are looking for tutoring, or if you're just looking for, somebody to comment, tell me that I suck, or I don't know, whatever it is, right? So that email is there for you. If you are looking for tutoring, my first hour of lessons is always going to be free. I say that in almost every video, I think. But in this one, I'm saying it right now. If you need tutoring and you're not really sure if tutoring is right for you, you can try it out risk-free. Just send me an email and we'll set something up. And of course, if you're, minor, then obviously talk to your parents first and all that, right? So anyways, 4720 in 99 and 33. Okay, so here's what we would do. If we want to do it without a calculator, and there isn't like a really good way, then you could just do it the old school way. 99 and 33. Right. So 9 times 3 is 27. 9 times 3 again is 27, but then I add 2 and I get 29. I'm going to scratch out my 2. Put a 0. 3 times 9 is 27. 3 times 9 is 27. Add a 2. 29. So then that's 7. 9 plus 7 is 16. 9 plus 1 is 10, plus 2 more is 12. 2 plus 1 is 3. Whew. Okay, so 3, 2, 6, 7. Man, they really started us off with a bang here. And then an n. They both have n's. So none of the numbers cancel, unfortunately. That's why number 1 is so hard. Starting off with such a hard question. But the n's do. Whatever n is, if n was 2, then it'd be 2 over 2, which is 1. If n was 3, it'd be 3 over 3, which is also 1. Right? So obviously you can only cancel it. You can only have n cancel if n is not equal to 0, but I don't think they care about that kind of stuff on this particular worksheet. So if your teacher is a stickler about that kind of thing, then you would want to maybe write off to the side or as part of your answer that n cannot equal 0. But I think most teachers are not crazy strict like that, so I don't think it matters too much. Your final answer would just be this. Minus the n's that I crossed out, obviously. And that's it, right? So super easy if you're using a calculator, not as easy if you're not. But as we go along here, there should be some numbers that are in common with other numbers as we go. Except for on number 2, because it looks like 43 is prime, 31 is prime, 53 is prime. Wow, lots of big prime numbers. Wow. Okay. Well, we'd have to multiply them out again. So if you're not sure how to multiply it this way, the old-fashioned way, you could just look up a video on that. I actually haven't done any videos on how to multiply things the old-fashioned way before people started doing Common Core multiplication. I don't have a video on that, but I'm sure if you go into YouTube and you type in like how to multiply the traditional way or whatever, something will pop up and you'll be able to see a video on that. So go check that out. I don't have any videos on that. I don't normally do videos on stuff like that because I started Algebra 1. So what I'm doing right now is like the lowest math that I cover. But there are lots of other people out there. So go check out somebody else if you want to do it the old-fashioned way. I'm going to just multiply it in the calculator because it's way easier and it's way less time. So 53 times 46 is 2438. Then 43 times 31 is 1333. So 1333. On the top there's an n squared. On the bottom there's a nothing. So we're done. I know they're not going to simplify because there's so many prime numbers, and not only that, but they're big prime numbers. If you have a bunch of big prime numbers, you're pretty much guaranteed to not have anything cancel. 46 is not prime, but it's 2 times a prime number, a big prime number, 23. So a lot of big prime numbers, and none of them are the same one. right? And prime means that it doesn't divide by anything except for itself and 1. So there's no smaller numbers that it divides by. So anyways, number 3. Hopefully, eventually, we can start simplifying some of these as we go. Oh, hey, yeah, we can. Look at this. Okay, so 93 divides by 3. And I know that because 9 and 3, if you look at the digits and all of the digits are 3, 6, or 9, then the number goes into 3 and sometimes 9. The other thing you could do is you could add the digits. And if the sum of all the digits goes into 3, then that number goes into 3 as well. So 93 divides by 3. 21 divides by 3 as well. 93 divided by 3 would be 31. 21 divided by 3 is 7. 34 is 2 times 17. 51, I believe, is 3 times 17. Actually. Yeah. Because 51 is 17, and then 54, 57, 60. Yeah, so both of these divide by 17, actually. So 34 divided by 17 is 2. 51 divided by 17 is 3. So by the way, this is the first time I've done this. If you're a little bit thrown off by this method, this thing that I'm doing right now, what I'm doing is I'm simplifying the fractions by dividing. If you divide or multiply the top number and the bottom number of a fraction, it doesn't change the fraction, because you're essentially multiplying by 1. Like if you multiply by 3 over 3, 3 over 3 is 1. So that's basically what I'm doing here, is if I multiply or divide the top and the bottom of a fraction, then it doesn't change the fraction, so I can't do that. And that's what I did. So I divided 93 and 27 by 3, and I divided 34 and 51 by 17. Now it's in lowest terms, because 31 is prime, 2 is prime, 3 is prime, 7. They're all prime numbers. So they're definitely not going to divide by each other now. Now it's going to be a lot easier to multiply across. Oh, and by the way, you can cancel out letters as you go as well, n over n. So I just do 31 times 2, which is 62, over. 7 times 3 is 21. And then there's one more n left over here. And that is it. So this method is, in my opinion, the best and the fastest way to multiply rational expressions. This will be the method that I'm using all throughout this video, and the one that I'll keep using, and I'll start going a little bit faster at, as long as each question doesn't have anything really that new going on. And that's kind of how I structure all these videos. So, moving on to number 4. 79, I'm pretty sure, is prime. 85 and 25 both divide by 5. Now, you might be thinking like, oh, wait, well, 85 is part of the second fraction. 25 is part of the first fraction. What are you doing? Well, I'm going to be multiplying across anyways. So all of the top stuff is really all together, and all the bottom stuff is really all together. I could rewrite it and do this, and that's actually the same thing, right? Just one fraction, just multiply the tops and the bottoms. That's what you have to do anyways, right? When you multiply fractions, you multiply the numerators, and then you multiply the denominators. So that's really all I'm saying is, well, if I'm going to have to do that anyways, then that means that I could divide 85 by 25. So I'm going to divide them both by 5. Oh, it's not going to result in 5. It's going to result in something else. Hold on. There we go. Okay. So if I'm going to divide by 5, the trick to dividing by 5 is to double the number and then slash a 0. Or if there isn't a 0 on the end, then you would move the decimal place one space to the left. That's a little harder to think about, but let's do it. So 85 doubled would be 170. Slash the 0, and you get 17. We just divided 85 by 5. And it works on 25 as well. Hopefully you already know that 25 divided by 5 is 5. But if you didn't, you could use the same trick, or if you just want to see if the trick works. Double it, 50. Take off a 0, 5. It works on everything, right? So if you want to divide by 5 really quickly, double it, take off a 0. Double it and take off a 0. 27 is 3 times 3 times 3. 79, pretty sure that's prime. So I think we're done here. And so we would just multiply across, and it's kind of pointless that I even do this. I think what I might start doing is I might start actually doing this in the calculator completely. One, to save time, and two, because if I'm going to simplify it, but then I'm just going to type it into the calculator anyways, then I might as well not even. So on the bottom, 5 times 27. So I will do that in a second, but just give me a second here. So I get 1343. So this is 1343. Oh, and one of the n's cancel out one of the n's on the bottom. N squared is n times n, so that's 1n for 1n. So we'll have 1n left over on the bottom. 79 times 17 is 1343. Over 5 times 27 is 135. Slap an n on there, and we're done with that one. Okay, now I am going to multiply across completely and just let the calculator do it. So I'm using a CI84 Plus. I also have some other calculators, but this is the one that I typically use because it has all my programs on it. If you're interested in math programs for SAT prep, then you can shoot me an email. Or if you're interested in programs just to help class go smoother, I have programs just for all the math classes between Algebra 1 and Calc 3 as well. So just shoot me an email if you're interested in that kind of stuff. But here's what I would do. I would do 96 times 25 divided by parentheses 38 times 45, close parentheses, enter, on my calculator. The other thing you could do is 96 times 25 divided by 38 divided by 45. You could do it that way as well. Just be careful when you're putting it all in the calculator. Make sure it works. I get a decimal. My calculator defaults to a decimal, but on a graphing calculator, if you hit math, on a TI graphing calculator, if you hit math, enter, enter, it'll rewrite it as a simplified fraction. So I get 80 over 57 as my simplified fraction. 80 over 57. And then there's an n on the bottom. Just slap that in on there, and we are done. And that's how you do it in the calculator. So if you have a different calculator, you might have a button that has an F and then a double arrow and then a D. That would also be a button you could press to switch from fraction to decimal, or vice versa. So moving on, I'm going to go ahead and type this one in the calculator. 84 times 48 divided by 3 divided by 95. Math fraction, enter. 1344 divided by 95. 1344 over 95. Looks like there wasn't that much simplifying that happened. It looks like it was 3 and 48 that simplified, because 48 divides by 3. And then that was it for that. Oh, and there's an X on the top. And we're done. And I forgot to change colors. Normally I change colors pretty often. Let's change to green. Alright. Now we're dealing with binomials. When you cancel out binomials, they have to be exactly the same. When you cancel out numbers, they have to be exactly the same as well. It's just that numbers are more easily divided by other numbers. If you have a binomial, it's a letter and a number. So we don't know what that divides by. We treat binomials like prime numbers. So if you have a prime number like a 3, and I divide it by like a 7, those are two different prime numbers. So I can't divide them. Now what if it was 6? Well, 3 doesn't divide out the 6, but 3 times 2 is 6. So then I can slash out the 3's, and then it would have 1/2 left over as my answer. Right? So I'm actually going to erase this because it's not really helpful as far as solving all of these problems. But that's the idea, is that when you're dividing numbers, you have to divide a number by itself for it to cancel. When numbers have common factors, you're dividing them both by whatever the common factor is. But ultimately, if you cancel something, it's because you divided it by itself. And that's what you have to do with binomials. You treat binomials kind of like prime numbers. they only divide by themselves, or a multiple of themselves. So for instance, r plus 2 and r plus 2, 6 and 6. 4 and 20 both divide by 4. If I divide them both by 4, I get 1. 4 divided by 4 is 1. And 20 divided by 4 is 5. So the only thing left on the top is 1 times r, which is r. And on the bottom, I just have 5. All right? So just be careful with binomials. Just because they both have the same letter doesn't mean you can cancel out the letters. They can only cancel out if the whole thing is the same. So that and that, that and that can cancel out here because it's completely by itself. It's not added or subtracted to anything. All right, so there's all the binomials that cancel right off the bat, and that's it actually, because the only thing left on the top is 7n squared, and then we have n plus 8, n plus 6 left over on the bottom. None of that's going to cancel because we have a monomial on the top and two binomials on the bottom. Even if you FOIL it out, it wouldn't matter. You don't need to. If you don't need to, then don't do it. P minus 3's cancel. 2's cancel. So P plus 6 over 4 is the answer. All right. Same thing over here. Let's see. R plus 4 and a 9. And I think that's it. So it's going to be 9R. Those are the only two things I didn't cancel. And then on the bottom, R minus 5. And you could put that in parentheses still if you wanted to. You shouldn't get counted off for that, but you don't need to, so. That cancels with that. 8, 8, 9 over 7m. That's it for that one. Okay. P minus 4, P minus 4. And looks like that's it. So P plus 6. Oh, not yet. I was about to box it. Too soon. P minus 4 times P minus 2. Just kind of leave them in parentheses. Don't multiply them if you don't need to. And there we go. Let me erase this. There we go. Okay, did I do 6 of those already? I did. I guess we'll switch on every 6. So we'll do a yellow now. Let's do a gold. That's a little easier to see. Increase the thickness by a little bit. Okay. Ooh. Okay, so now we're getting to where we have to actually try to factor out stuff from our binomials and trinomials. So if we do that, then this one would be 10. If I factor out 10, I would have v plus 3 left over. And then on the bottom, I'm going to have v plus n, v plus 3. That marker's a little bit too thick. I'll change it on the 14th one. Those cancel. And so that's your answer right there, 10 over v plus 10. Let's change it back a little bit. Just go a little bit thinner. All right, 7n's cancel. And looks like we can factor some stuff out from the top and the bottom. 9 and 24 both divide by 3. On the bottom here, 24 and 64 both divide by 8, I believe is the GCF. So 8n squared. 24 divided by 8 is 3. Oh, wait, hold on. That should be a 3 right there. Okay, there we go. 3n minus 8. I missed the 3 there. 3n minus 8. And then the 3n minus 8 cancel. And there's our answer. Okay, that was 2, so I have 4 more. Okay. Let's see. Oh, now we have a trinomial. All right, so in order to factor a trinomial, and by the way, as I start factoring more and more stuff here, basically the idea is that I'm kind of going to recap factoring a little bit, but not a lot. I've done a lot of other videos on factoring, so I'll probably have some in the description below. If you are watching this video later on and I don't, then you can slap me on the hand and throw an angry comment in the. Anyways, you can just tell me if I forgot, but hopefully I'll remember to put in the description some other factoring videos that I have where I show you how to factor and all the different kinds of factoring. But let's go ahead and factor. So on the top, we're going to have x plus 7 this right here. Then right here, we need two things that multiply to 40, and they have to add or subtract, in this case, subtract to -3. So that would be 5 and 8. 5 times 8 is 40. We want to do positive 5, -8. Positive 5 times -8 is -40. Positive 5 minus 8 is -3. So positive 5, -8. All right. Then on the bottom, we can factor out a 7. And I have x plus 5 and x minus 8. Look at that. X minus 8s, x plus 5s. X plus 7 over 7 is our answer. Moving on. We have some binomials, so we don't need to do trinomial factoring on this one at least. But let's see. So we can take out a GCF of 20a on the top. And then we'd have a minus 5 left over a minus 1. And then here looks like 16 is going to come out. 16 times 5 is 80, so 16a squared. So I'd have a, 80 divided by 16 is 5, so that'd be minus 5. All right, so that cancels with that. 1a cancels with 1a there. 20 and 16 simplify as well. So that's a 4 and a 5. They both divide by 4. Whew, lots of stuff that cancels. Okay, so I don't have a 20 anymore. Don't have an a anymore. I don't have an a minus 5 anymore. All I have left on the top is a 5. On the bottom, I have a 4 left over. I have an a left over. Right? And then I have a minus 1 in parentheses left over as well. Okay. Whew, that was a little harder than I was thinking it was going to be. And that is 4 so far of my yellows. I have 2 more yellow problems. I don't know why I'm such a stickler for this, but I like to keep switching colors. I guess I think it keeps it lively. It's just something for me to do. And also I have ADHD. So, let's see. So 3. You can factor out a 3 and a b. So b plus 6 is left over. All that's times by 1, so that doesn't really turn into anything. And then I have b plus, I don't know why I wrote 8 first. Whatever, it's fine. B plus 8, B plus 6. Doesn't matter what order you put them in if they're being multiplied, so kind of worked out better that way anyways. 3b over b plus 8. Boom, done. That's it. Number 18. We've got p plus 7 times p plus 2 over p minus 10 times, here we have 7p plus 14, so that's a 7 that comes out, and then p plus 2 left over. P plus 2's cancel, and on the top now, all I have left over is p plus 7. On the bottom, I have a 7. You don't have to put the numbers first. You could write it as parentheses p minus 10, close parentheses, and then dot 7, just like how it's written here. But you don't have to write the dot if you write the number first, because it's assumed that you're multiplying. So it's literally me just being lazy and not wanting to write a dot. Is what that is. How many more do we have? Several. Okay. Let's do this. So next up is orange. I guess we can do like a blood orange. Is that red orange? I don't know. I guess we could do orange. But this orange doesn't look that much different from this gold right here, so maybe we'll do a blood orange. Okay. So 21x, that's the GCF of that. X minus 1 times 6x. On the bottom, looks like 18x is the GCF. Then I have x minus 1 left over times 6x squared. Oh, and by the way, we could have canceled that out pretty much right off the bat and just have an x left over on the bottom. So I'll go ahead and do that, actually. That'll save some time there. Well, it would have. It doesn't anymore, I guess. And then now there's just an x on the bottom there. Right? So 6 is canceled. X cancels with an x on the bottom with 1 x left over. All right, so then that cancels with that. Those x's cancel there. 21 and 18 to both divide by 3. If I divide 21 by 3, I get 7. That's all that's left over on the top. 18 divided by 3 is 6. and an x. And that's it, because everything else canceled. Okay, moving on. Now we have a trinomial again, so we need to factor it. I need two things that multiply to 20. Let me show you, because earlier I just kind of did it. I was also kind of running out of space, but let me show you what I mean. So when we factor, we want to do a number times a number equaling that number, and they have to add or subtract to the middle number. Factors of the last number, what times what gives you the last number, and the same what times what becomes what plus what equals the middle. So -1, positive 27 make -27. If I add them up, I would actually kind of be subtracting. -1 plus 27 would be 26. That's not 6, so I keep going. What about 3 and 9? It doesn't divide by 2 because it's an odd number, so 3 and 9. And it looks like that works. -3 times 9 is -27. -3 plus 9 is positive 6. So that is how you factor it. Okay, and that's just on the top. On the bottom, you have p minus 9, p plus 9. P minus 9, p plus 9. Plus 9s cancel. And you have p minus 3, p minus 9 left over. Okay. Kind of wrote kind of big. Oh, I know why I'm writing really big. It's because I made the marker thicker with the yellow, because yellow is sometimes harder to see. Let me make the marker less thick, so it's a little easier to write more in a smaller space. Okay. V minus 7s cancel right off the bat. Don't even have to wait to do that one. 10, and then v plus 6 over, look at that, v plus 6. The answer's 10. All right. Now let's see. 5r plus 50. Factor out of 5. And you have r plus 10 times r minus 2 over r plus 10 times 5. So 5's cancel, r plus 10's cancel. R minus 2 is the answer. All right, that wasn't that bad. Oh, spoke too soon. Number 23. Which one are we on? Got two. Oh, we got two more, and then we'll switch another color. All right, so factors of 25 are going to be 5 and 5, both minuses. This is going to be x minus 5, x minus 5. I could also have written x minus 5 quantity squared, but I have a feeling one of those x minus 5s at least is going to cancel out, so I'll write it out this way so it's a little easier to see which one is canceling and which one is left over. 10 factors out from here, x minus 10. And over here, a 9 factors out. Since you normally want to have the x out first, because all the other things are written with x first, this one's kind of written a little funny. Since we want to keep the x as just an x, I would probably factor out a -9. And if I factor out a -9, then this would just be x, and 45 divided by -9 is minus 5. Be really, really careful whenever you're dealing with negatives, but that's how you would do that. Because you want the x to be by itself, because all the other x's are by themselves. You want it to be positive, not negative. And you want it to be kind of in the same order, in the same form, of the same kind, of the same type. So it's easier to see when you can do this. 1 and 1 cancel. I can't cancel both, only 1 for 1. Right, so then I get my answer. I've got x minus 5 over 10 times -9 is -19. That's the answer for that one. All right, moving on. We have, let's see. Well, it would just be the 45x squared at first. But then this will factor into, let's see, 3 and 12? No. 4 and 9. Yes. Positive 4, negative 9. Positive 4, negative 9. Okay, because 4 times -9 is -36. 4, what was I saying? Oh, 4 minus 9 is -5. There we go. On the bottom, x minus 9. And 3x squared with x plus 4 left over. Right, x plus 4s, x minus 9s. 3 and 45 make 15. 45 over 3, that is. And the x squareds cancel as well. Wow, this one really, really simplified. It went all the way down to just a number from all that. That's crazy. And now we're on the last 4. I'm a little bit over time for today, so I normally try to put out all of the content that I do by 4 o'clock sharp. But this one, I'm running behind today, so I apologize. I'm going to skip straight to purple, just because the red looks really close to this kind of orange. This is a stronger orange. So I'm going to skip straight to purple. And I don't really like the color red anyway, so. 8 and 56 both divide by 8. So take out 8, v minus 7. Then over here, 18 is 9 times 2, but that won't work. How about 6 times 3? Ah, yes. So x plus 6, x plus 3. All right, 6 times 3 is 18, 6 plus 3 is 9. Boom, got it. Okay, on the bottom, we can factor out an 8. And we'd have v plus 6 left over. Over here, we can factor out an 8v, and it would have v plus 3 left over. All right, so v plus 3s, some 8s, v plus 6. Oh, I wrote x, but I meant to write v. Kind of the same thing, sort of, kind of. So everything cancels on the top except v minus 7. And everything cancels on the bottom except 8v. And so that is our answer. Whatever's left over is the answer. All right, lots of 9s. Goodness gracious. So many. One thing you could do, actually, is if everything divides by a number, all the terms, that is, if they all divide by a number, then you could divide all of them by the number instead of having to factor it out first. So you want to be careful doing it that way because it's kind of a faster trick method. So I would practice doing it that way first and make sure you're still getting the right answer before you get that down. But here's what I'm saying. All of these numbers look like they divide by 9. So just divide them all by 9. Divide that by 9, divide that by 9, divide that by 9, divide that by 9, divide that, divide that, divide that, divide that. If we got rid of all the 9s, now it's pretty much fully simplified as far as numbers go. What about the letters? Well, they all have at least one R. So we can get rid of a power of R. One less power of R would be R2. One less power of R2 would be R. And normally I would just slash the 2, but because there's a lot going on, I'm going to just rewrite it as R, just so I don't miss it. That one would completely go away. 1 R left over there. That one goes away. 2 R's left over right here. 1 goes away there. Okay. So after all of that, we would have R squared. You still have plus and minus and times and stuff, so we would still write all that out. R squared minus 6R. And R plus 1. Okay. Then on the bottom, I'm going to have R plus 5. And R squared minus 6R. Whew, okay. So I'm still going here. This is crazy. But it does normally get harder. That's normally how math has gone. That's pretty much how it's always gone for me. It starts off easy and then it gets harder as you go. Let's see. Well, we can factor out an R on the top and on the bottom. Actually, you know what? Hold on. This is easier. These are the same thing. R squared minus 6R. R squared minus 6R. That's the exact same binomial, so we can just cancel that out. That's easier than doing what I was going to do. If you didn't see it, you could, factor out an R and then get rid of it from there. But you don't have to. Not if it's exactly the same thing on the top and the bottom, which it was. And actually, it was the same thing on the top and on the bottom from the beginning as well. I didn't even notice that. I could have done it from the very beginning. Canceled them out, but it's all good. So that is our answer for that one. And now we're on the final 2. And by the way, if you've been finding this helpful, if you've got all the way to the end, you must have probably thought it was helpful, or you're just you just feel bad for me and you're just watching it, to give me that extra runtime, but you just as a pity, But probably not, right? You're probably watching it because it's been helpful. So if it has been helpful, go see other things that are helpful. I've got tons of stuff on my website. Got all kinds of resources on there. I am going to have all of these solutions, so like all the work, put on my website. I'm going to have the videos on there as well as all over YouTube as well. I put everything on YouTube. Some videos that I'll have on my website won't be on YouTube. So go check that out if you want to see all of the things. And that's where I keep all of my stuff is on my website. So go check that out if you want to see any other free resources. One of them in particular, if you just go to the main page, myersmathematics.com, it's called The 5 Math Mistakes Everyone Makes and How to Avoid Them. It's basically just a PDF. All you have to do is look at it and read it, and it'll help because it's exactly what it sounds like. I made the title really long, but it's very on the nose. It's exactly what it is. It's the 5 math mistakes everyone makes and how to avoid them. So it's literally what it sounds like. So if you're intrigued by that, go check that out and see what it looks like, and then let me know if it was helpful or not, or what I can do to improve it. Always want to try to get better at helping you guys get better at math, so you can get the grade you want to well, you want to get the grade you want to get, and then from there get into better, advance to the next class and graduate and move on and do other things, and maybe do more math later on. Maybe you'll have to take college algebra, all that kind of stuff. So let's see, this will be minus 10 and plus 1. So plus 1's cancel, minus 10's cancel, and I believe that's about it. So the answer of this would be 8 over 3 m plus 5. That's it for that one. Now we're on the last one. Okay, here we go. Challenge accepted. Oh, hey, remember earlier I was saying we could have canceled something out right off the bat? Look at that. 6n plus 6, 6n plus 6. That's the same exact thing. It cancels. Ah. Okay, so 27 is 3 times 9. So we want to do n minus 3, n plus 9. Because we want negative 3 plus 9 to be positive 6, and negative 3 times 9 is negative 27. On the bottom, we have n plus 9. That cancels, and n minus 3 is actually the final answer. That really wasn't that bad for it being the last problem on the worksheet. So that is it. That is it. And we'll go ahead and scroll down to like a slow-ish scroll. You can check out the answers. You can also just Google this worksheet and find all these answers. This isn't something I did. I just got this off the internet. That's what your teachers normally do when they assign you worksheets, is they just Google things and grab it off of the internet. And that was the inspiration for doing this whole series. So go check that out, and Google it if you need to. Let me know if you want this this thing here. You can find it on my website as well, or just let me know in an email. And have a great one, and I'll see you in another video real soon.